Welcome to Cadence Pointwise Tutorial Tuesday, where we show you how to use a feature or demonstrate a technique in just a couple of minutes. In this video, we're going to present an overview of the automatic volume mesh functionality introduced in Pointwise version 18.5. The objective of the automatic volume mesh functionality is to allow you to go from a surface grid to a volume grid as fast as possible and with as little input from you, the user, as possible. We have also put in the code all the best practices to generate the base volume grid that you might need. In order to access the new functionality, I'm going to select all my domains, go to Create, and then the second option is the automatic volume mesh functionality. As soon as you enter this functionality, you're presented with two options. The first one is create volume mesh boundaries, which is the one we're going to use. If you select this option, the software is going to create that far field, the bounding domains for you. If you select the second option, Pointwise is going to use any existing volume mesh boundaries that you might have. So it's going to try to form a closed volume and use that to basically create or assemble your block. Like I said, in our case, we're going to be using the create volume mesh boundaries. So the software is going to create those boundaries for you. So I'm going to click here. And as you can see, you're presented with this. So let's focus for a minute on the display window. So if you look at the display window on your right, you can actually see that you have your initial surface mesh. And then you have a few items that have been added in there when you enter this functionality. You have a small box, which is called the extent box, and is the smallest box that you can define that will contain the entire surface grid. Then you have a big box that is a preview of your far field, and I'm going to show you in a minute how you can change the size in the different axes and how you can actually change the shape of this far field. But this is a small preview of the current far field that the software is creating for you. And you can also see that you have several yellow axes in there labeled L1, L2 for length, W1, W2 should be there, but is detecting symmetry, that is for width, and H1 and H2 for height. I mentioned that the W2 axis is not there, and that is because Pointwise is automatically detecting that loop that you see there rendered in green as a symmetry, and is going to use those connectors to create a symmetry domain. Okay, that's why the W2 with two axes, it doesn't show up in there. So that is what you have in front of you in the display window. So let's move a little bit to the left to take a look at the panels briefly. You can see that you have three tabs that this functionality is going to present to you: the global tab, the boundary conditions tab, and the advanced tab. So I'm going to present a brief overview of some of the options that you're going to be using here, but please keep in mind that we do have detailed videos that go through each one of these panels and all the options in a lot more detail. So the first thing you're going to find here is the far field mesh frame. And let's take a look at the options you have in here. The first thing in line is the type. So you can decide whether you want an unstructured volume grid or a voxel volume grid. In our case, we're going to select the first option for unstructured. The second thing in line is the shape. We have in here three options for the shape of the far field. In our case, currently we're creating a box, but you can also choose to create a cylinder or a sphere. If you pay attention, you can see that all the different entry fields that are presented here are going to change, of course, depending on the kind of or the shape of the far field that you would like to create. In our case, we're going to create a boxed shape far field. The next thing in line is the center option. So basically, this allows you to decide how do you want those yellow axes to be defined. If I zoom in a little bit closer, you can actually see those yellow axes. They start at the center of the geometry. I have in here that little yellow dot. That's where everything starts. And the information that is right here that I will describe in a minute of the sizes for your far field, they're all computed starting from this center point. Now, if you were to choose the other option right here, you can actually see that those yellow axes now are not defined or starting from the center point of the geometry, but from the faces of your extent box right there. The next thing that you have in here, hopefully, is clear. Basically, you have several entry fields to define the dimension of your far field, whether it's a box, a cylinder, or a sphere. You're going to have different entry fields to define the appropriate numbers for how big or small your far field is going to be. In this case, again, we have a box. You can see the first field over there is uniform. So if you want your box to have uniform size in all different axes, you can just go ahead and type a number in there, and you're going to have a uniform definition for that box. Then you have entry fields for every one of those axes. If you want to, for example, L1 and L2 to have a dimension that is different from everything else, you can of course do something like this. As you can see right now, L1 and L2, when I change this number, they're going to have the same value, but you have this option right here that will allow you to specify independent numbers for, in this case, L1 and L2, and the different axes have, of course, the same options in there as well for independent definitions. Okay, so these are all the options that you have in the far field mesh frame, and actually by the time you're done with this definition, the shape of your far field and just like some of the basic options, like for example the grid type, those are going to be defined. Once that is done, you're going to move to the next frame, which is the boundary mesh. So you have two options right here in the boundary layer option, and I'm going to show you these with the option turned off. So hopefully it's going to clear things up a little bit. So the boundary layer option allows you to decide whether you want boundary layer in your volume grid or not. Obviously, setting these to off, that means that you're not going to have a boundary layer, and of course your volume grid is going to be purely isotropic. If you were to want a boundary layer, you're going to go to what you had before, which is the geometric growth option over there, and of course this is going to expand the panel with several more options that are pertinent to the creation of anisotropic cells. In particular, the ones that I want to point your attention to is the wall normal spacing. So you can enter right there what is the initial spacing of those anisotropic cells as they grow off of the surface grid that you have in front of you. The next option is of course the growth rate that has a default value of 1.2, and this number is going to indicate how fast those anisotropic cells are going to be growing. The next frame right here is the extrusion stop conditions, and you have 4 options in there that you can modify. And basically those options are going to define when the creation of those anisotropic cells will locally stop. The options you have are the collision buffer with a default value of 2, the final cell aspect ratio with a default value of 1, the max included angle with a default value of 170 degrees, and last but not least, the centroid skewness with a default value of 0.8. Now, all these numbers, of course, you can go ahead and change them to something else, but we have defined in here numbers that are based on our best practices and our experience in the creation of this type of volume grids. The next tab that we have in here is the boundary conditions tab, and this is where of course you're going to be defining the boundary conditions for the creation of the, in this case, boundary layer. As you can see, when you enter this tab, you're going to be presented with this table that has defined 5 different boundary conditions by default. Those are the isotropic, the boundary layer, the match boundary conditions, symmetry, and periodic. So what is happening here is these boundary conditions are created automatically for you, and their type, as you can see, is also set up automatically for you, and for these 5 default boundary conditions, the type cannot be changed. What you can change is the delta value, whether it's appropriate, of course, depending on the type, and the value of the adapt feature for each one of these default boundary conditions. So with these boundary conditions, Pointwise is going to try to automatically put domains in those boundary conditions as Pointwise understands your grid. For example, in this case, you can actually see that 50 domains or patches of surface grid have been automatically added to the boundary layer boundary condition. So domains will be added to the boundary layer boundary condition in an automatic way when those domains are actually constrained to an underlying database surface, which is the case for all those domains. Then you can see that we also have one domain that has been assigned to a symmetry boundary condition, and it's that one right there that is rendered in that cyan color. You also have here some boundary conditions that were automatically generated, but they're not used. For example, you have the match boundary condition. Any domains that are not constrained to an underlying database surface that are also adjacent to domains assigned to a boundary layer boundary condition, those domains would actually go to a match boundary condition. We don't have any of those in here, and that's why that's 0. And of course, if there are any periodic domains in your surface grid, they will be automatically assigned to the periodic boundary conditions. Everything else that doesn't go to those boundary conditions, of course, is going to be automatically assigned to the isotropic boundary condition. So in my case, this is looking very good. Now, there's some other cases where Pointwise is going to do an assessment and put domains where it thinks they need to go, but if you need more control, of course, you can create new boundary conditions, define whatever name is more appropriate, the appropriate type over there for those boundary conditions, and you're going to be define any delta value that might be appropriate. Okay, so once a new boundary condition is defined, you can of course assign domains to that boundary condition by simply selecting those domains from the display window and then click here, or you can use this functionality over there that will allow you to define a new pattern here that will basically look domains with names with that pattern, in this case all these domains, and automatically assign them to that new selected boundary condition. So this is actually very handy when you have a large grid. And of course, like I mentioned, this works with the names of the domains that you have selected to enter this functionality. In my case, I'm going to delete these. I'm not interested because my boundary conditions are already well defined, as you can see right there. So I'm good. Last but not least, we have the advanced tab, and this is very likely one of those tabs that you might not get to use a whole lot unless you have a particular application where you really want a little bit more control. So that is the point of the advanced tab. We put tools that are very important, but we're very confident that the numbers that we assign to those parameters based on our experience in mesh generation, they're going to be something that you probably can use. But if you need a little bit more control and you need to modify these options, of course, we also give you that opportunity. So as you can see, there are like 3 frames right here. The first one is the symmetry frame, and it allows you to decide whether you want to specify symmetry planes manually or automatically. As you can see, you can define up to 2 symmetry domains, and if you decide to do it manually, we give you all the options to do so. In my case, the automatic definition is perfectly fine. The second frame is the spacing controls frame, and you have 2 options in there, the decay and the background spacing. These 2 options, again, they're like predefined for you with numbers based on our experience and the kind of surface grid that you have and the kind of volume grid that you want to generate. And we're confident those numbers are most likely going to work for you. However, you can change them if you need to do so. These 2 numbers are actually going to be used to compute the size field that drives the generation of the volume grid. And last but not least, if you were actually creating a voxel volume mesh, we give you the option here to change the value of the min edge, max edge, and the number of transition layers. In our case, we are using or creating an unstructured grid. So once you're done with all these definition, and like I said, it is very likely that you're going to work with the global and the boundary conditions tab most of the time. For some special cases, you might have to change something in the advanced tab. But once all this is done, I'm going to click in here the create volume mesh option, and I'm going to let Pointwise use all that input that I have defined to create or assemble my block. Now, if you have used Pointwise before, you're probably familiar with the fact that at this point, that volume grid has been assembled, has been created, but inside it is actually empty. So if I go to the list panel right here, you can see a new block was created. It's unstructured, but it's empty, it has no cells inside. And that is because it needs to be initialized. There are two options right here. Basically, you can check that little checkbox in there and allow the code to initialize that volume grid for you when you click OK in an automatic way, or you can actually uncheck that, hit OK, the volume grid is going to be created but empty, and then you can initialize it just the regular way, pushing the initialize button. In my case, I'm going to allow the code to initialize it for me when I click OK. Okay, after a few seconds, Pointwise has finished, and we can notice a couple of things. That domain right there has been correctly understood as a symmetry domain. So let's go ahead and very quickly perform an examine cut in here, right there, for example, and you can actually see how the T cells were created. That domain is understood as a symmetry domain, as expected. And we can see the growth of those very nice anisotropic cells for here, for example, here in the propeller. The last thing I would like to show you before wrapping up this overview is how to create a block for an internal flow simulation using the automatic volume mesh functionality. As you can see in front of you, I have the exact same quadcopter. The difference is that we don't have half the quadcopter, we have the entire quadcopter. And on top of that, I also have some internal geometry going on. Actually, if I zoom in a little bit closer, you can see what that geometry looks like. We have some components to make it a little bit more interesting. Now, the intention here is to basically select all these domains that you have in there, all these central domains, and use the same functionality to create that block for an internal flow simulation. So I'm going to select all the domains. I'm going to go to create and then automatic volume mesh. And I'm going to hit enter right there. And of course, you're presented with the same two options that we saw before. In this case, I'm going to use the second option, use existing volume mesh boundaries, because I want to create that internal block. Now, when I click this option, the first thing Pointwise is going to do is to check to make sure that all the domains that you have selected to enter this functionality actually form a closed volume. If they don't, if you have an open volume with those domains, Pointwise will let you know with a warning message, and it's going to render those free edges that are causing problems in bright red, so you can actually see them and go and fix the problem. In this case, everything should be fine because I do have a closed volume. So when I click the second option right there, I can enter the functionality just fine after passing that check. Once you actually enter the functionality, you can see everything is going to look very, very familiar. You have the global boundary conditions and advanced tabs with options that are appropriate for this internal volume grid that you're trying to create. In this case, as you can see, everything is the same. In this case, I'm not going to create a boundary layer, just we already saw what that looks like and how to create it. I'm going to go ahead and click on create volume mesh. So very quickly, Pointwise is going to create that internal block for me. Now, right here, we have the exact same little checkbox that I saw before. So The moment I hit OK, Pointwise is going to not only finalize the assembly of that block and exit these tasks, but it's also going to initialize my block. Let's hit OK. And as you can see, Pointwise is right now initializing my block. And like I said, since we don't have a boundary layer, this is going to be only an isotropic volume mesh. After just a few seconds, the block initialization has finished, and I can do a very quick examine cut plane over there to take a look at my grid. And as I mentioned before, this is an isotropic grid. I did not create a boundary layer in this case, but you already know how to do that from this video. So if you like this video, be sure to click the thumbs up button, subscribe to our channel for more videos like this. If you have any questions or suggestions for future videos, drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a pleasant Tuesday.